Lesson 1-2, Powers and Exponents. Suppose you text message one of your friends. That friend then text messages two friends after 1 minute. The pattern continues. How is doubling shown in the table? You can see here that multiplying by 2 is how you show the doubling. How many text messages will be sent after 4 minutes? Well, if you continue the pattern, 4 minutes would be 2 times 2 times 2 times 2, or 8 times 2, which is 16. What is the relationship between the number of 2's and the number of minutes? Well, 0 minutes here in this row and 0 2's. 1 minute, 1 2, 2 minutes, 2 2's, 3 minutes, 3 2's, 4 minutes, 4 2's. So the number of minutes matches the number of 2's. Two or more numbers that are multiplied together to form a product are called factors. When the same factor is used, you may use an exponent to simplify the notation. The exponent tells how many times the base is used as a factor. The common factor is called the base. In this example, the factor is 2, used as a factor 4 times, written as 2 to the 4th, gives us a value of 16. This table points out a couple of things that students should know. A number written to the second power can be read as 5 squared, or 5 to the second power, but many times is read as 5 squared. So any factor to the second power is referred to as squared. Any factor to the third power can also be referred to as cubed. So this number could be read 4 to the third power or 4 cubed. Numbers expressed using exponents are called powers. In these examples, you're writing powers as products. In the first example, 7 to the 5th power means 7 as a factor 5 times. 1, 2, 3, 4, 5. In the second example, 3 as a factor 2 times, 3 as a factor 1, 2 times. In these check your progress problems, 6 to the 4th power then would be 6 times 6 times 6 times 6. 1 to the 3rd power, 1 times 1 times 1. 9 to the 5th power, 1, 2, 3, 4, 5. 9 is a factor 5 times. You can evaluate or find the value of powers by multiplying the factors. Numbers written without exponents are said to be in standard form. So in our first example, we would evaluate 2 to the 5th by first of all writing out the factors. So we would write 2 as a factor 5 times. Then we start multiplying these two numbers together. We would have 4 times 4 times 2, which is 16 times 2, which is 32. 4 as a factor 3 times. 4 times 4 is 16. 16 times 4 is 64. To check your progress, 10 is a factor. 2 times 10 times 10 is 100. 7 to the 3rd would be 7 times 7 times 7, which would be 49 times 7, which would be 343. 5 is a factor of 4 times. 5 times 5 times 5 times 5 would be 25 times 25, which would be 625. The major mistake people make here is they multiply the base times the exponent. So in many cases, students here would think 7 to the 3rd power is 21. 5 to the 4th power would be 20. As you can see, those are obviously incorrect answers. Numbers written with exponents are in exponential form. So 3 as a factor 4 times could be written as 3 to the 4th power. In these examples, 5 as a factor 3 times would be 5 to the 3rd power, or 5 cubed. 12 as a factor 6 times would be written as 12 to the 6th. Simply count the factors. The base is the factor the common factor. Write each power as a product of the same factors. So 9 to the third power would be 9 times 9 times 9. 3 to the fourth power would be 3 times 3 times 3 times 3. 8 to the fifth power, 1, 2, 3, 4, 5. 8 to the fifth power. 8 is a factor 5 times. Evaluate each expression. 2 to the fourth would be 2 times 2 times 2 times 2. You might remember this from before. Could do it this way. 4 times 4 is 16. 7 to the second power would be 49. Notice I'm writing them out in factor form. 10 to the third power, 10 times 10 times 10, which is 100 times 10, which is 1,000. Problem number 7, it says there are approximately 5 to the 10th people living in North Carolina. About how many people is this? Well, if you try to write this one out, it gets very difficult. There's 5, 6, 7, 8, 9, 10. Then you start multiplying those out and you get a very large number very quickly. This would be a problem where it would be permissible to use a calculator. 5 to the 10th, you can see in standard form, is 9,765,625. So a lot of multiplying would go on there. Write each product in exponential form. 1, 2, 3, 4, 5, 6. 5 to the sixth power. 4 ones would be 1 to the fourth power. 5 fours would be 4 to the fifth power. Simply count the factors. Becomes your exponent. The base is the common factor. These are the answers to the problems we just did. You can go back and check those if you'd like after you're done. These are the vocabulary terms from this lesson. You'll notice there are quite a few. You're responsible for knowing them all. They're in your book. They're on the website. You should memorize them. You'll be evaluated on them at some point during the chapter. At this point, you should return to the Scott Highlands homepage. Go to Moodle Login. You'll see this page. They'll ask you for your username, which is your student number, and then your password is the first 6 letters of your last name and your 2-digit birth date. For example, mine would be BEARD02.